another sheet from yesterday, 515, but not the one you picked up today, the one you received yesterday. Brilliant. All right, so we're gonna start with the part about average rate of change, even though we've done it several times before. Clearly, based on the mid-unit quiz, a lot of you still don't know how to do it. Why? I don't know. So let's review it again. Anytime you see a problem that says find the average rate of change, what equation should be coming to your mind? Good. If you don't know that, make a flashcard or something. There's like a few things you need to know. You need to know exponential functions, that equation, linear equation, and then like the average rate of change equation. All right. I have some kids that seem to think it's like x1 minus y1 over x2 minus y2. It's not. All right. It is that. Other ways to remember it could be, this is also known as your slope formula. So like rise over run. So change in your y's over change in your x's. Also another formula. Another way that I think about it is like miles per hour, which is totally unrelated to this problem, but how you go through about that is the same. It's your average rate of change. So like say that I went on a 2-hour drive and I traveled 150 miles. All right, what's my mileage per hour, or what's my average rate of change? What's 150 divided by 2? 75, thank you. So then you would say that that is 70 miles per 1 hour is what I drove. Not necessarily, like I could have went really fast for some of it and then pretty slow for another part of it, but on average, that's what I drove. So that's like the same concept here. Like if we're looking at a loan, I'm finding the difference in my final amount minus my starting amount, how much time has passed, and I'm averaging it and figuring out about how much was accrued each year. All right, that's what we're doing. Maybe that'll help you, maybe not, but you need to have that formula memorized because you had access to that formula on your quiz, and yet I think in all my classes, maybe like less than 10 people got it. All right, I don't get it. So let's practice. We won't necessarily, it says find it for each function. I'll tell you exactly which one to use. So we're going to find the average rate of change in part A from the start of the loan and the end of the second year for function A. All right, we came up with that equation yesterday, so I'll scroll back up to it. That's the one that had the 12% interest. So we made this equation. All right, so I'll even rewrite it for you. Y equals 1,000 parentheses 1.12 to the x power or to the t power, whatever you want to use. In part B, I'll have you do it for function B rather than have you do it for every single one. And notice that that one is from the end of the 10th year and the end of the 12th year. So also let's copy down the formula for function B. That one was where the rate was 24%. So y equals 1,000 parentheses 1.24 to the x power. Now, they would never make you solve for average rate of change without giving you all the information you need. Sometimes they're nice and they give it to you in a table, or they give it to you in a graph. In this case, and how it was on your quiz that you most recently took, stop talking, take a second. It gave you an equation, and you had to know what to plug into that equation so that you can get your correct coordinates. So for like function A, if it says it wants it from the start of the loan and the end of the second year, well, would time be my X or my Y? It's your X, so you'll be changing the X each time. When it's at the start of the loan, what is X? No. So like when no time has passed, what is X going to be if X is time in years and no time has passed?
Yeah.
0. What about at the end of the second year? If X is years, then what would the end of the second year be? X value of 2. Then plug that into your equation, find your outputs for those, then find your average rate of change. For B, if it says at the end of the 10th year, then what is my X? 10. At the end of the 12th year, what is my X altogether? Class, what is my X? That was 2 people, that was not all together. Are we paying attention? At the end of the 12th year, X would be what? At the end of the 13th year, X would be what? At the end of the 100th year, X would be what? So that's all it's asking you to do. It would never make you do that without giving you all the information you need. So now that you have the equation, now that you know where your X's are going to be, find your output, then find the change in your outputs divided by the change in your Y's. Okay, I'll give you 3 minutes to try that within your groups. All right, table 7, did we get a final answer for part A that I asked you to do? Did we get a final answer for part A, the rate of change for the start to the second year? Right, we already had time to figure this out. I asked the question, let's keep it moving. So table 7, did we get an answer? Yes, no? Okay, so let me ask you other questions so that you can get there. What did I tell you to do with these X's? Or what do you think you need to do with these X's? Given the equation? Just go with the time side. Okay, we'll go. All right, so let me put it this way. If at the start of the loan, we said that X is 0, that's where we're gonna put in that 0. Just table 7. If this is function A, and you notice that there's a Y and an X in there, where would that 0 go? Into the X. I don't know how I give you guys time in class and then you still you don't ask for help, you don't say anything, but like, it's that easy. I helped you guys set it up. So then table 7, either put that in your calculator or solve it by hand. What's my output when X is 0? $1,000. All right, so my very first coordinate is what's my X? Table 8, what's my X in this one? No. I don't know how we're not paying attention. Like, this is like killing me. I'm not asking you guys really hard questions. You guys are just not paying attention. Table 1, what is the x in this problem that we just did? Table 2, what is the x in the problem that we just did? No, that is not the x. Table 3, what is the x in the problem that we just did? 0. For the love, when x is 0, we got that y is 1,000. Then coordinates go in the order x, y. You write 0 first. And then what is my y, table 4? 1,000. So you need a coordinate, whether it's in a table, whether it's in a graph. If they give you an equation, you might have to solve. You plug in the x, and then you find your y. That's what we just did. Question. All right, so we're not done yet because we only have one coordinate. What other interval did they tell us we need to solve for? Table 5. No. Table 6. What other interval did they ask us to solve for? For at the end of the second year. We already set this up. We know that x should be 2, so guess what? Guess where we're putting the 2? Class. In the x spot. In the same equation, because we're finding average rate of change for function A. We still haven't found the average rate of change. So we're not on part B yet. So then table 7, when I plug in the 2, what do I get? $1,254.4 and then nothing else, or is there more numbers? I feel like there's more numbers, so let me pull it up.
It's always rounding.
Like your calculators are already rounding for you? Okay, well, whatever setting that is, take it off, because you shouldn't be rounding until the very end. Or use a different calculator. You all have access to Desmos. All right, this one's fine, actually. All right, so yes, you guys are fine. I think I was thinking of a different one that we did earlier. All right, but any rounding, don't do it until the very end. So then, what was my x in this part for year 2? Table 8, what was my x in this one for year 2? What was my y? No. Table 1, what was my y? Table 1, you're 0 for 2. That is, I don't know how to make this easier. Table 2, what was my y? No. Table 3, what was my y? All right. These are paired together because when my input is 2, my output is this. All right, we're not going to pair with the other y. That wouldn't make any sense. We pair with this y because that's what we got. Make this one x2, y2. And now you can plug it into your average rate of change formula. Questions there? All right, so then the way that I labeled it, table 4, what's my y2? Good. Table 5, what's my y1? 1,000. Table 6, why do I have a minus sign in between them? Sorry, what was that? Because it's in the formula. Couldn't really hear you, but assuming that's what you said. Table 7, what is my x2? Guys, two with the labels, yes, thank you. Table 8, what is my X1? Zero. Good. So don't skip that labeling step, because for some reason, a lot of you like to mix them up. It would look like this. Notice these are paired together because they're from the same coordinate, the 0 and 1,000. Notice they are on top of each other in that fraction. This one that's paired together when we solve for year 2 is also on top of each other in the fraction. You cannot have them from the same coordinate be diagonal from each other because that's when you labeled it wrong and plugged it in wrong. All right, this part we could do in our calculator all at once, or you can probably solve some of it and then put it in your calculator. But whatever gets you to the right answer. 1254.4 minus 1,000 on the top, that's my change in my Y's. That's the difference in the money owed over my inputs, which is usually time of some sort, 2 minus 0, because we're looking from the start to the end of year 2. And that's my average rate of change. So if you got that your first try, great. If not, hopefully you're learning something because you'll see it over and over again, like I told you in the beginning of the year, but that's what it would be. The average rate of change is 127.2, was it? Yes. All right, and since we're talking about money, let's make it look like money. What does money round to? Table 1, what does money round to? Table 1. What was that? The 100th spot with the TH. So then how can I make this look more like money? Class, how do I make this look more like money? Good. That's our average rate of change for function A, part A, from the start to the end of the second year. Allison, I'll let you go to the restroom if you can correctly tell me what 1B is. Did you already calculate it? Okay, then figure it out, show me, and then I'll let you go. Otherwise, everyone else, you all need to be here for this because everyone almost everyone got it wrong, even though it was like a semester 1 concept as well. So sorry, this is more important. All right, so then table 2. What is my first step in solving part 1B? Plugging in the X for the 10 because it wants it at the end of the 10th year. So you have to figure out, well, how much money was owed at the end of the 10th year. So plug that in. Table 3, what would that Y value be? So kind of do it in your head. Either you already have it done or pull out a calculator and do it. Point 42. Is that what you said? Is there more decimals? Okay, so guys, try not to round till the very end, because depending on if you round early, depending on what the numbers are, it can change your final answer. So maybe, and I know we're rounding to money, so I get, let's say 2 decimal spots, but maybe at least do like 3 or 4 just while we are working this out. So 8,594.42, and let's just round it to 4 spots for right now. At the end, we'll make it look more like money and round it to just 2 spots. All right, but good otherwise. At least we know how to use a calculator. Table 4. What is my next step?
Or 1B.
For 1B. Make the coordinate. So what would my coordinate be for this problem we just did? Okay, good. So the input that we decided we needed to check since they want it at the end of the 10th year. So X would be 10, and that Y value when X is 10. All right, good. Table 5, what would I do next? So instead of the 10, it's now going to be the 12. And guys, remember we were doing function B for part B, so that's why the parentheses are different. All right, but otherwise the time affects the exponent. So now make it a 12. Table 6, what is that value? All right, are there more decimals? Okay. So good. Even rounded right, but just for like good practice, I'm gonna put 4 decimal spots until the very end. All right, so then what's my coordinate from that table 7? What's my coordinate for the part we just solved? Remember, coordinates go X and then Y. So what was my X in that one? Good. What was my Y for that one? We already found it. No, it's not 13,000. So what you get from putting it in the calculator, that long number. So we see that where the X is 12, and then once we solved it, this is the Y class. All right, so once you have your 2 coordinates, make one of them X1, Y1. There goes X and then Y, so this is my first set of X's and Y's. And then X2, Y2. And then what do I do with them, table 8? If we put on. Because the average rate of change formula. The change in Y divided by your change in X's. So the way that I labeled it, table 1, what's my Y2? Good, that long number, the 13,001. Table 2, what's my Y1? Good. Okay, sorry, you can't really see it in there, but yeah, that one, other long decimal for the output. Table 3, what was my x2? And table 4, what was my x1? Looks like I'm gonna topped out. Sierra, what's my x1? Good. All right, this you could put in your calculator and make your life easier, or you could subtract each and then divide them. But this is really it. I don't think this is hard. I think it's just knowing how to use a calculator and knowing how to find your coordinates. So sometimes they give you a table, sometimes they give you an equation, and you have to do some calculations. And so this is my average rate of change for function B. And yes, now we can round it now that we're at the end. And since we're talking about money, round it to 2 spots. So is it gonna be 0.18 or 0.19? 0.18. All right, so on average, from year 10 to year 12, function B with the 24% interest had that much owed each year. Questions? Okay, so that's average rate of change. We're gonna move on. Do you have questions on average rate of change? Okay, so actually, I'm gonna give you time to work on your lesson 15 practice. Literally 15 minutes, I'll put you on a timer. And really focus on those average rate of change problems, because those are honestly so important. You'll see them over and over again, and there's no reason we should be getting them wrong. So lesson 15 practice for 15 minutes. So at 10:15, we're gonna move on. Allison, do you need to go? Okay, so you can go now.